In this video, we'll learn about rusting. We'll learn about the chemistry of rusting and the conditions that are necessary for rusting to occur. Rusting is a type of corrosion. Corrosion is a natural process that affects metals. Rusting specifically affects the metal iron and some iron-containing alloys. Rusting occurs when iron is exposed to oxygen and water. This forms a number of iron-containing compounds. But the primary compound in the substance we called rust is hydrated iron 3 oxide. When iron rusts, a reddish-brown substance forms on the surface of the metal, which is the hydrated iron 3 oxide. This doesn't just change the color of the metal, it also changes the properties. Iron is a strong and durable metal, but rust is weak and brittle. Rust is so brittle because it has a tendency to flake off the surface of the metal. When the rust flakes off, it can expose the metal underneath to oxygen and water, which will cause that metal to rust and flake off the surface of the metal, exposing more of the metal to oxygen and water, and so on. This can cause the metal to degrade over time. Iron is also more dense than rust is. This means that rust has a greater volume than the same mass of iron will, so iron expands when it rusts. An iron part that expands when it rusts could cause damage to surrounding parts. Another difference between iron and rust is that iron is a conductor while rust is an insulator. So a part that's made of iron won't be able to conduct electricity if it rusts. Rusting can also cause parts to become stuck together, something you may have encountered if you've ever tried to unscrew a rusty bolt. If we compare rusting to other forms of corrosion, rusting is particularly damaging. For example, aluminum will corrode to form aluminum oxide. As we learned, hydrated iron 3 oxide will flake off the surface of the metal, exposing more iron to oxygen and water, causing it to rust. Aluminum oxide, on the other hand, does not flake off the surface of the metal. It forms a protective layer on the aluminum, preventing further corrosion. Aluminum and aluminum oxide also have more similar volumes than iron and rust do, which means that when aluminum corrodes, there won't be damage caused to surrounding parts. Now let's take a look at the chemistry that's involved in rusting. There are many reactions that are involved in rusting, but we'll just be looking at the main ones that are involved in the formation of the hydrated iron 3 oxide. Rusting starts when iron metal dissolves in water, which forms iron 2+ ions and 2 electrons. Since iron is losing electrons, this is oxidation. Whenever something is oxidized, something else must be reduced. And that something is oxygen gas dissolved in the water. The oxygen gas reacts with hydrogen ions that are also dissolved in the water, as well as the electrons that are given off by the iron. This will form water. Next, some of the iron 2+ ions will be converted into iron 3+ ions. These iron 3+ ions react with water to form iron hydroxide and hydrogen ions. The iron hydroxide will be slowly converted into hydrated iron 3 oxide. There is an N here instead of a number of water molecules because there's a number of different hydrated iron 3 oxides that can form. The overall chemical equation that describes rusting is 4Fe plus 3O2 plus 2NH2O, reacting to form 2Fe2O3 NH2O. But you'll often see it without the water molecules for simplicity. There are several factors that will affect the rate that iron will rust. The most obvious factors are exposing iron to oxygen and water. If we can minimize the amount of oxygen and water that iron is exposed to, we can slow down the rate that rusting will occur. We can protect the iron from oxygen and water by coating it in some way, such as by painting it, oiling it, or galvanizing it. Rusting is accelerated if the iron is exposed to salts. This is why cars tend to rust so quickly in areas where they salt the roads after it snows, and why boats that are in salt water rust more quickly than boats that are in fresh water. The reason for this has to do with the fact that rusting involves the transfer of electrons between iron and oxygen, and electrons are able to move more easily when they're in electrolyte or salt solutions. Rusting is also accelerated if iron is exposed to a low pH. There are several reasons for this. The first is that a low pH environment can remove the coatings that are protecting the iron from oxygen and water. Recall that a low pH means that there is a high concentration of hydrogen ions. A high concentration of hydrogen ions means that we have an electrolyte solution, which will allow the electrons to move more easily, just like we saw with salts. Hydrogen ions are also directly involved in the redox reaction between iron and oxygen. A high concentration of hydrogen ions means that more atoms of iron are oxidized into iron 2 plus ions, which will eventually form rust. With that, we've covered everything we needed to know about rusting. So now that we're experts on the topic of rusting, let's try some problems. Which of the following word equations correctly describes the process of rusting? A. Iron plus oxygen plus water reacts to form hydrated iron 2 oxide. B. Iron plus oxygen reacts to form iron 3 oxide. C. Iron plus water plus air reacts to form hydrated iron 2 oxide. D. Iron plus oxygen plus water reacts to form hydrated iron 3 oxide. E. Iron plus hydroxide ions reacts to form hydrated iron 3 oxide plus water. Rusting is a type of corrosion that affects iron and some iron-containing alloys. Rusting occurs when iron is exposed to oxygen and water, which forms a reddish-brown substance on the surface of the metal. This substance is hydrated iron 3 oxide, which has the chemical formula Fe2O3NH2O. There is an N here instead of the usual number of water molecules that are in the compound. This is because there's a variety of different hydrated iron 3 oxides that can form. So the word equation that describes rusting is iron plus oxygen plus water reacting to form hydrated iron 3 oxide, which matches answer choice D. Though the question didn't ask for it, the corresponding chemical equation is 4Fe plus 3O2 plus 2NH2O reacting to form 2Fe2O3NH2O. Put the following tubes in the order in which rusting will occur, starting with the slowest. Each tube contains a nail with different conditions. Rusting is a type of corrosion affecting iron. Rusting occurs when iron is exposed to oxygen and water, which forms hydrated iron 3 oxide. This means that any measure we take to protect iron from oxygen or water will slow down the process of rusting. The process of rusting is also accelerated when iron is exposed to salts or a low pH. Tube E is the only one where the nail is exposed to salt water. Since rusting occurs more quickly when iron is exposed to salts, rusting will occur the fastest in tube E. In test tubes A, B, and D, measures have been taken to protect the nail from oxygen or water. But in test tube C, the nail is exposed to tap water and oxygen from the air. So rusting will occur more quickly in test tube C than in test tubes A, B, or D. If we look at test tube D, the nail has been protected from water by a stopper and the addition of anhydrous calcium chloride. Anhydrous calcium chloride is a desiccant, which means that it can absorb any water that enters the tube. This will protect the nail from water for a long time, meaning that rusting will occur the slowest in this tube. Now we just need to determine whether rusting will occur more quickly in tube A or in tube B. In tube A, there's no water, but the nail is exposed to the air. Air has some amount of water vapor in it, meaning that water will eventually make its way into the tube. In tube B, measures have been taken to protect the tube from oxygen in the air. The tube is stoppered, and there's a layer of oil. However, this tube is full of tap water. There's always some amount of oxygen gas that's dissolved in tap water. This means there's already both oxygen and water in the tube. So rusting will occur more slowly in tube A than in tube B because it will take some time for water vapor from the air to enter the tube. So putting the tubes in the order that rusting will occur, starting with the slowest, is D, then A, then B, then C, then E. Now that we've had a chance to look at some problems, let's summarize what we learned about rusting. Rusting is a type of corrosion that affects iron and some iron-containing alloys. Rusting occurs when iron is exposed to oxygen and water, which forms hydrated iron 3 oxide. The chemical equation that describes rusting is 4Fe plus 3O2 plus 2NH2O react to form 2Fe2O3 NH2O, which you'll frequently see represented without the water molecules. Rusting is accelerated if iron is exposed to salts or a low pH.